So, we are here with Surajit Paul in front of his poster at the SKA Science Conference in Goa. And this poster is about the prospective discovery of filamentary inroads and visualization shocks of galaxy clusters using SKA1. So Surajit is going to tell us a bit more about his work. So yeah, Surajit, thanks very much for being with us. Just tell us, a bit about what you're working on.
Yes, thank you. Actually, the universe is full of structures. You see long filaments, and they are connected by the nodes, and that nodes usually the galaxy clusters. But till date, our telescopes are not sensitive enough to detect the filamentary structures. It has only detected the nodes like galaxy clusters and some of the bigger groups. So those region like filaments and all are completely remained unobserved till now. But this SKA telescope gives us the extreme level of sensitivity, which makes it possible to observe some of the hidden material that we can actually see from the filaments. So yeah.
So where will we be able to see, with SKA at the start, where will we see those first filaments?
Yeah, so in SK with SKA1 we can expect that this where the filaments are going into the clusters, taking the cold material into the clusters, there due to this cold material falling into the clusters meeting with the hot material, there will be instability, turbulence in those regions that will amplify the magnetic field in those regions and accelerate particles, and that will be seen in a non-thermal radio emission which SK is going to detect. So that can be seen. But till date, the other wavelengths like X-ray, they could not detect it because those are cold gases and does not emit much.
So that's with SKA1. What happens with SKA2?
So SKA2, as I predicted from my models, that SKA2 will be able to detect the full of the filaments. Those are connecting the galaxy clusters. So that will reveal most of the unseen matter, which is called missing baryons in the universe. Those will be detected. About 30-40% of that missing baryons will be detected by SK.
Can you tell us a bit more about those missing baryons? What do they mean?
Yeah. So when universe started, so the another field of research is the cosmic microwave background that shows us the earliest in universe that we can see, and from those data we see that there were huge amount of baryon at that time.
So a huge amount of matter.
Which radiates. That kind of matter was a huge amount. But if we see today that our observation in different wave lengths like optical, X-ray, radio, all together we can produce only 50% of those baryonic matter or radiating matter that we can only see. So where this other 50% gone? So from our theoretical model, we can see that those are hidden in the filaments and smaller groups of galaxies in the universe, which form the cosmic wave structure.
So that would help us to solve that problem that we've had for a long time. Part of that problem.
Yes. It's almost 30-40 years people are searching for that, but are not able to detect them yet. And that problem will be solved. Like we can see missing baryon in plenty with the SK.
Right.
So
can you show us on the poster with those filaments? Those
yes. So these are the simulated filaments, the material, baryonic material, and this is the temperature map of this. But if we think about the detection, so we have plotted the X-ray emission. It cannot see the filamentary regions in
What
the.
is it that you see on the left image?
This is the X-ray image.
Okay.
Possible X-ray image for the this filamentary structure that I have shown earlier, but these filaments are missing there.
So
But
at the center is a huge.
yeah, only center part will be detected by the present X-ray telescope, not even the outskirts.
Yeah, and what is it that you see at the center? It's a huge.
It's a huge mass, that galaxy cluster we call galaxy cluster, that mass.
Yeah.
But if we see, if you can close it more, if we can see that there are filamentary structures seen in radio waves, which we have modeled to actually see whether that could be seen by the SKA, and our prediction shows these filaments will be detected by the SKA. I mean when that will be in full operation, that will detect all the
Okay,
portions.
so you can see the filaments. That's what you see. Can you describe for me what those are?
Yeah, these are the cold material falling into the galaxy clusters. These are the channels that bringing the cold material from different parts of the universe to the galaxy cluster.
Okay.
And there is another thing. So these are the I mean very energetic shock waves that will be also detected. At this moment we can detect only these central shocks, but SK1 may detect this second level of shocks, so multiple shocks will be detected, and possibly SK2 will have the capability to detect these extreme level third or fourth level shocks, which are called the virialization shocks.
And what causes these shocks?
These shocks are causing by the galaxy cluster merger, which is the energetic most event in the universe, releasing the highest possible energy that we can think of. That amount of energy, when released during the cluster merger, they form shocks, and those shocks are actually will be only seen in radio waves. It cannot be seen any. It will be detected by the SK. Yes.
Okay. Great. I think that's. So thanks very much, Surajit, for your time. We're live from the SKA Science Conference in Goa, and we're at the poster session, which was kindly sponsored by Nature Astronomy. So thanks very much, Surajit, and see you next time. Bye bye.
Bye.